All right, folks, this is the first episode of Every Day's a School Day, a new podcast that I've launched. And I'm very, very grateful for Dr. Ryan Morgan to be my first guest. I've been working with Ryan for probably the last 3 months before Christmas. So, Dr. Ryan Morgan, a bit of background, is a psychologist in brain health and performance optimization based here in Melbourne. Ryan's company is called NEURO Performance. You can check it out at neuroperformance.com.au. NEURO Performance uses an integrative whole systems approach to optimize brain and mental health. Ryan is a registered psychologist with postgraduate training in non-medication based approaches for addressing conditions for such as sleep disorders, ADHD, stress, burnout, depression, anxiety, and peak performance for students, athletes, and professionals. Ryan has also studied nutritional medicine, neurotherapy, clinical hypnosis, epigenetics, and has brain health coaching with the famous Daniel Amen from Amen Clinics. Is that how you pronounce that? Amen or Amen?
Amen. Amen.
Amen. Amen.
I think it's
cool.
Amen in the US.
Right.
Yeah.
Okay, cool. So thanks again for coming on, Ryan. I suppose my first question is, how did you go from a regular psychologist into the field of brain health psychologist? Like, I'd love to know that transition and what prompted you to go down that specialization.
Sure. Look, back early in my career, I was actually working in disability services, doing a lot of assessments on intellectual disability, and I actually came across a field called neurofeedback, which interested me. Partly because it just seemed to have more of a science bent to it, whereas at that stage I'd found psychology was kind of a little still abstract in many ways. And so my science mind sort of really wanted to grab onto something, and neurofeedback just seemed to be it. And through training in that, I learned as it emerged about brain scans, these things called quantitative encephalograms or quantitative EEGs, and how we could see different things in the brain that represented or showed us these functional disorders that we'd been studying, I suppose, in all the textbooks at university. And that was my starting interest. But over the last probably 5 to 10 years of my career, I've really started to follow the works of several international psychiatrists like Dr. Amen and Dr. James Greenblatt, and the works of specialist doctors, Dr. Dan Stickler, who is a bit of an epigenetics specialist, but also, they all kind of specialize in this area called peak performance. So, and, all of them were using DNA testing, we're using quantitative EEGs to look at the brain. And one of the arguments of Dr. Amen is psychologists and psychiatrists are really the only medical professions that do not look at the organ they treat. Every other profession, an ophthalmologist will look in your eyes. I mean, even your doctor will listen to your heart or look at your bloods or, do scans of your brains, your chest, your lungs, you name it. So, why do we not do that? And I kind of felt hooked by that because it just made intuitive sense. And yeah, that's just how my kind of interest at looking more at the brain came about. And yeah, just to finish that off, through that journey, realized at how much all of us focused at everything from the neck down, and the general functioning of the brain and the health of the brain just was ignored. Even in the preventative space was ignored. And the relevance of that being Alzheimer's disease, as a possibility of being able to prevent that. And I'm going, wow, I mean, what's going on? And so that started my kind of interest and passion in understanding the brain, but also not in isolation, understanding the brain as a part of a whole system, and that is actually the most important thing that we need to do is you have to understand the whole system, from the gut all the way to the brain, because they're all interlinked.
Yeah, you definitely bring another level to holistic healthcare, because that's I suppose the main thing that I was drawn to you whenever I was doing my research. It was, you look at blood work, you look at our DNA testing, you look at the microbiome, gut health, and then the brain scan. Like, I approached you due to terrible sleep. That was my main thing that was drawing me to you, and you had lots of evidence that we could look at the brain, do a QEEG brain scan, and it would tell, it would give more data to understand what's really going on, because it's not always going to be, say, stress in life. It's not always going to be too much caffeine. It's not always going to be sleep apnea, like all of these different things that I've been researching as well. So that was the real cool thing that attracted me to your work. And what was it that, whenever you linked all of those modalities, like when did that come about? Was that part of this whole process? Did the brain, did you start looking at the brain first, and then that led into the blood work, the DNA? How did that roll out?
Yes, look, I've always been interested in nutritional medicine as well. Even as a child, it was probably the passion I should have followed. But yes, out of looking at the brain, looking at EEGs, and starting to do research to understand what these changes meant. Some were, as you mentioned, directly just representations of terrible sleep, right? And maybe that's all you can confirm. But there were also certain, what we come to term phenotypes, commonly found patterns within the general population that also had some strong genetic evidence behind them too. And so, the more I dug into the research literature around QEEGs and did training sessions with some of the experts overseas, I was able to kind of see that there are multiple things that our brain's EEG will represent, from inflammation somewhere in the body, blood flow issues, even things like toxic metals, heavy metal toxicity. Some of these things, we've got documentation of how the brain's EEG will change under those exposures, including, say, drug use, marijuana use, for example. So, the more I looked at that, I realized it's not a diagnostic tool as a standalone in its own right, but it can give you a window into understanding what the potential causes might be in the background. And then we can use that to work on a whole systems model to try and help that person address the underlying drivers of whatever causing the brain-based disorder that they're suffering from.
And what would you say most of your clients would come to you with currently? Like, what's their sort of number one issue that they come to try and explore with you?
A large percentage is ADHD, for sure. Kind of fashionable at the moment in
Very
some
trendy
ways, but also, there's definitely, I suppose, a lot more talk going on about it. So a lot of people who are and have gone most of their lives undiagnosed are certainly, investigating now the possibility of it. But broadly, even without that question, it would be the complaints of brain fog, difficulty concentrating, memory's really not functioning very well, always been good, and now post-COVID struggling with memory and it just hasn't recovered. That seems to be the sort of lion's share. There certainly is a percentage there of interested biohackers, like yourself, who may not specifically be experiencing anything that is, you would regard as a disorder or a struggle, but they are looking to just take themselves to that next level, or see if there's any risk factors that they can continue to work on and prevent, which to me is actually quite an exciting area opening up in the world of EEG, which maybe we can even talk about, which is this thing called brain age, right? We all kind of talk about DNA aging and being able to see whether your body's aging quicker than your actual age. Well, there is data now emerging around some very complex algorithms that will allow us to do the same with your brain, to actually look at your brain's age. Is it aging more rapidly than your biological age? And what does that mean, and what can we do about it?
Oh, and what would cause it to age quicker? Like people thinking more, or people using their brain more would make it age more, or people with genetic disorders, different things. Like what's the main thing to make a brain older than it is the person, kind of thing?
Sure. Yeah, quite the opposite. Thinking more and doing more with your brain will be one of those protective
Oh,
factors.
okay, cool.
Yeah. What we're looking at is broadly lifestyle factors that are likely to be contributing to this. So the most significant I would see is issues with sleep. So not getting enough sleep. For those getting 6.5, 6 hours or less, the damage that actually does to the brain over time is quite significant, quite profound.
You just called me out. I get
Yes.
6.5 hours.
I do like that. But look, we can talk for hours on the importance of sleep and just all
Yeah.
the data around it. But yeah, so broadly, inflammation, if you think of it as neuroinflammation, what drives this buildup of inflammation in the brain? And yes, sleep deficit is one. Diet is another. So leaky gut, people might know of, and leaky brain are sort of terms. They are well documented in scientific literature. So they're not kind of alternative medicine or woo-woo. But, when the bowels are not good defense systems, when they're permeable, they are letting in a lot of bad stuff. And that, by and large, ends up in our brain, causing and driving inflammation. So inflammation is what really seems to be the outcome of this poor diet, of poor sleep, of sleep apnea, which is an oxygen deprivation. I mean, that's even more significant and harming, but there is inflammation. Alzheimer's disease, is ultimately a brain inflammatory disorder. All of them seem to end in this thing called inflammation, and that's what seems to degrade and slow the brain down. So by brain age, when we're talking about the EEG, we're talking about a slowing broadly in the background electrical activity of the brain.
Yeah. And sugar would be a culprit too, wouldn't it?
Sorry? Say that again?
Sugar would be a big culprit for the inflammation in the brain.
Absolutely. Yeah. Yeah. Because it's broadly an inflammatory molecule. So is alcohol. So is caffeine. So is wheat. So the list goes on to our dietary factors that do drive inflammation. And if we've got robust gut health, robust immune systems, we may be a little defended against some of that. But over time, with that kind of a diet, you will whittle away at the integrity of your gut, and eventually that inflammation will start to be an issue.
Yeah, so that's you explain why you've came to this full circle of the gut, the blood work, the DNA genetics, and the brain, because as you said, it's all interlinked, and you can't have one without the other. As you said, you can't have a standalone.
And more than that, Pete, I think something that we don't talk about a lot in the world of psychology and psychiatry around these diagnoses, depression, schizophrenia, bipolar, ADHD, all of these conditions, there's this assumption and an inaccuracy, I think, that often gets perpetuated by the kind of medical world, that there's one cause. ADHD is a genetic disorder. Well, that's not entirely true. It loads the gun. Certainly there is a much larger genetic heritability in ADHD than any of the other disorders that we know of. But research very, very confidently concludes that there are multiple other factors that come together, birth, post-birth, early childhood years, that can drive ADHD. And so, we've got these terms that we use to say that most of these mental health conditions are multi-cause, and therefore we need to actually address them in those multi-cause areas. It's probably why antidepressants don't work for a lot of people, or why we have to go through several different types of antidepressants before we find one that may be effective. If it was one single straightforward cause, that medication should work in at least 90 to 100% of the cases. It just doesn't. And the same applies to ADHD. You have to go through 3, 4, 5 of the kind of types of medications that are there. And yes, in that family of medications, the research supports around 90% of patients with ADHD will improve. But why not just with Ritalin? If it was just that issue, then Ritalin should address all of those patients, but it's not. So, we know that there are multiple different systems, multiple different factors that come to create your version of that condition and my version of that condition. So it just makes logical sense that we need to understand and try and work out what those causes are, and that any treatment plan should not just focus on just the drug or just the counseling, or it needs to be a whole systems, including what I kind of call my NEURO program, right? The NEURO is my way of trying to capture all the areas that I believe we generally should work on to make sure we try and capture those multiple system causes.
Yeah, can you share that acronym, Ryan, just with the listeners? Because I thought it was just neuroperformance. I didn't know it was an acronym until you shared that it was. So neuro's nutritional.
Yeah, so we know neuro kind of refers broadly to our neurology, the brain, but neuro, the N stands for nutrition. And so that really is just a catchphrase to cover everything from what we're putting into our body, as well as the things that we need to take out of our diet, the toxins that are generally also contributing. It includes your gut health in that mix as well. So that's really broadly my nutrition space. The E stands for exercise. So certainly we know the benefits of exercise are extremely well documented, probably more effective than any prescription antidepressant. Extremely helpful in conditions like ADHD, helps reduce inflammation. So it just does so much. But the same exercise is not having the same benefit for every human being. So trying to tailor and understand, that's where DNA comes in, what exercise may actually be more beneficial to that individual versus the other. The U stands for unwinding. So just this ability to relax and disconnect from the kind of stressful life that we live, because stress certainly is right up there with those significant drivers, those significant causal factors of a lot of the things that we suffer. So not sleeping is actually a stress response. It creates an oxidative stress environment in the brain. So stress we have to manage. The R is restorative sleep. And we could have a whole couple of hours just talking about what that really means. But overwhelmingly, the data, is in support of at least getting between 7 and 8 hours of sleep, for adults, and 9 to 10 as children, and those getting around the sort of 6 hours or less. The list of diseases and illnesses and cancers that are actually related to that is, again, well researched and well documented. So.
And there is a gene, isn't there, Ryan? That there's a gene that people can operate on like 4 hours of sleep, isn't there?
Not 4 hours, no. So there are variations that we can potentially inherit in what we call that epigenetic space. That I would say around 5% of the population may carry those variants, and they could lead to needing slightly more than that 8 hours, so maybe needing 9 hours, or needing slightly less, so about 6.5. So we really don't seem to drop below
Okay.
6.5. But that would be, broadly a very, very small percentage of the population. And just because you carry that variant doesn't mean that that's actually how it's being expressed, right? So that's another whole topic too. But so the vast majority of people need to be aiming for that 7 to 8 hours of
Yep.
sleep. And then the O is kind of my optimizing the brain, and that really is there to just look at all of these emerging technologies, these existing technologies that we can use to, say, directly interface with the brain itself. And that can be from things like neurofeedback, a kind of brain training, probably not the most accurate term, but a brain training platform to, yes, there are games people are aware of that you can play on a daily basis to strengthen certain function in the brain. There's even one for ADHD now. That's
On the app, on the phone, isn't it? I think I've seen
FDA
apps.
approved, as
Okay.
a kind of prescription only treatment in the US. And right through to peptides. What kinds of peptides do we know? Nasal spray versions of peptides that actually get into the brain and actually change things, can enhance memory. So there's a whole field out there on using that. To nutraceuticals, which might fall under nutrition, but nutraceuticals are really more kind of brain optimizing supplements that have a non-stimulating effect. Through to transcranial direct current stimulation, putting a low-grade current in the brain, or pulsing electromagnetic frequencies into the brain. There is an explosion in the space of wearables on the head, caps that you can change the way the brain functions by stimulating the front or stimulating the back, activating, deactivating to help you sleep. So that's the space that I kind of enjoy playing in, and helping people optimize their brain with these emerging technologies.
Awesome. We could probably talk about whenever I came and got my my brain scan done with you. It was an experience. It was one of your colleagues that carried the procedure. I didn't know that I should have washed my hair before I came, so I had to wash it there to get all the grease and grime out of it. Product. And then they put on the hat with the electrode spots, and then they put gel in each of those little holes. It was like a swimming cap. And then the gel probably took about half an hour probably to get on and get all lubed up. And then it was all the wires were hooked off into a computer. And then we started the process. I was sitting on a chair, and we done 4 minutes with eyes open and just sitting relaxed, and then 4 minutes with the eyes closed. Am I right what I'm saying?
Yes. So everything you've described are absolutely accurate. It is an EEG cap, an electroencephalogram cap. And traditionally in the hospital systems, there may be a lot more electrodes. So I think the one you had about 19 electrodes and 2 ear clips and a couple of things stuck above the eyes, all looking to measure things like your heart rate and your eye movements to help with cleaning the EEG. And yes, they inject a conductive gel into each of those. And that's why they ask you to wash your hair, because, the salt solutions, or a lot of the gels and pastes that have sodium in, that salt layer on the scalp would make your whole head a big conductor. Right. And so, we would end up picking up the light fittings in the room and the plug power points, electricity. And so, you're really looking to isolate just under the little electrode the piece of, the spot of gel, so that you are targeting just that spot and only the electricity coming off the surface of the brain in that spot. It's shorter recording than what you'd get in a hospital, because they're certainly in the world of neurology. an EEG is their tool to explore why a person might be having migraines. So they're looking for signs that there could be something more sinister going on, tumours, things like that. But predominantly, they're looking for epilepsy. So they would do much longer overnights, 24-hour day, 2 days, 3-day recordings
Wow.
to look for possible seizure activity. With what you did, we don't need those long because we're not working in the space of neurology or reading an EEG like a neurologist would. Those shorter recordings are enough to be processed through a system called a quantitative EEG system, which is trying to look more at the average amounts of the different ranges, the different frequencies that we produce in our brain, and then compare that against a normative database of male brains your age that have been pre-screened for head injuries, medical issues, any form of disorder, right? And so we might call that a normal brain, whatever that might be. That certainly is in debate. But we compare to see whether you deviate excessively, not just somewhat, but statistically it has to be relevant, how much you deviate away and in what parts of the brain. And so that's why we don't need to have a long
Yeah, it's
recording.
just a snapshot.
Yeah.
So I'll never forget whenever I go. We'll go through the results of my brain scan just to show people, but I'll never forget. You said it's no wonder you're not sleeping too good. That was your words. Just whenever
Yeah.
you saw the results of my brain. Can you bring up my brain results, Ryan?
Yeah, sure.
And then just gives people an understanding of what it is and what it looks like, and the alpha delta waves and stuff. It's very interesting. Like, I'm fascinated by it.
Let's try and see if we can share to that back. There we go. So would you like me just to
Yeah, just talk
do a bit
about
of a quick talk through what we're
a
looking
quick,
at?
yeah, eyes open, eyes closed, and
Yeah,
the difference and what it should be. Like, you were
sure.
pretty amazed that when my eyes were closed, it was pretty much as if my eyes were open, which would
Yes.
obviously make
So
sense when it comes to bad sleep.
as you mentioned, there's an eyes closed and an eyes open. So what we're doing when we're recording this EEG is we're looking at you not active, in a resting state. So sitting with your eyes open, you're not doing anything, you're not doing maths or problem solving, you're just sitting quietly staring ahead. So that is regarded as one resting state. But the brain is still quite active. There is input coming in the eyes, and we're thinking, and we're alert, and we're awake. So the brain's EEG should look reasonably active. Okay? The eyes closed would be a more of a resting state. And we're really comparing the eyes closed and the eyes open. We would expect to see the vast majority of the EEG should look similar between those two states, because even in your eyes closed, the only change that's happening is that you're not getting visual input coming in the eyes. So right at the back of your brain, in the occipital lobes, we should see a change in the eyes closed. And what I mean by change is that the brain's EEG, instead of looking active and small and fast and kind of sped up, there'll be these larger, big bursty waves of a wave called alpha. And that is like an idling rhythm, because effectively your visual centers, it's like pulling on the park brake, they're idling, right? No input, so they idle. And you'll see these large waves, these large up and downs at the back. As soon as you open your eyes, that should get suppressed. In other words, that alpha should disappear, and it should then just look like the rest of the brain. Okay? And that's what we're expecting. So when we see something different in other parts of the brain than that transition, that's what we would start to look a little bit more closely at. So in your eyes closed, it's worth sort of looking at that state first, and I won't go into all of the EEG, but these are all the squiggles, the up and downs that are happening. And on the left, these are all the electrodes that were attached to your scalp. F for frontal, T's stand for the temporal lobe on the left. This is the motor strip across the top. T4 is the temporal lobe on the right. And then we go a little bit more into the temporal parietals towards the back of the head. And the O is the occipital lobes. That's that visual center. And this is an EEG that's in its raw form, and we've got little heartbeats going on, little heartbeats echoing throughout, and that's not real EEG. So our system will automatically work to clean it, and as practitioners we would also go in and we look through that raw to remove things called artifacts, things that are not real, eye blinks, chewing, swallowing, a bit of head
Twitching.
sway, things that that affect the EEG cap itself and can create these waves that are not actual EEG. Okay. And so we do that and we end up with an EEG that looks a little better, a little cleaner. And I can already look at this EEG, and from this alone, in your eyes closed, can tell that you were drowsy on the day. So
I think it was like
I think
10
that's
o'clock in the
really
morning.
important. Sorry, Pete?
I think it was 10 o'clock in the morning, but again, this is something that I experience, is these drowsy spells a lot during the day.
Yeah. And, we're trained to look at this so that we don't overinterpret EEG, because this is not pathology or something to be concerned about in the EEG itself. This is a state change. When we close our eyes within the 3 minutes, and it's partly why we don't do 15-minute recordings, is because around 8 to kind of 12 minutes, that's when your brain will start to drift off into a drowsy, sleepy state. Okay? But within a 3-minute recording, we don't expect to see that. And if we do expect to see, or if we do see that within that 3 minutes, the brain's state has changed, you're reasonably confident that there is a diagnosable sleep disorder there. So alone, that would allow me to go, Pete, what's going on with your sleep? This is quick and chronic, so there must be some kind of an ongoing sleep disorder. Sure, if you had 4 hours of sleep the night before the EEG, we may see the same thing with you drowsy. But if it's just been a predictable pattern, no, I'm getting 6.5 hours every night and I'm confident in it, I would look at this and say, that's not enough, right? Your brain looks very sleep deprived. And that's the standout sort of pattern where we get these bursts of an alpha wave here. We expect to see them at these two electrodes at the bottom, at the back, and then it just disappears. It goes away. And then we'll get a big burst of it again. If I scroll across, you'll see big burst, and then we get these moments where it disappears, and then it might burst again, and then it totally kind of goes away. And then we get slower looking patterns like this, which is sort of suggesting that you were really getting drowsy now, all right? Moving into a very sleepy state. So why is that relevant? It's helpful for us to say that you've got a sleep problem, but you wouldn't overinterpret this and say, that's the pattern of ADHD. Your brain is too slow and under-aroused. You would say that looks more like a sleep-deprived brain. If we can fix your sleep, that would be the priority, and then relook at your EEG to see what's left.
Okay? Yeah.
Now, we can make it a little easier for discussion with clients is we can use these colorized maps, okay? And what they're doing is they're doing the hard work for us. It's effectively looking, and we'll look at this head here. There's a nose and a left ear, right ear. We're looking top down on the head, and each one of these black dots was where an electrode was placed on the head. So that one was above the right ear, that one's above the left ear. And what this system will do is it will go through each electrode and it will only measure how much of the slowest brainwave delta you make. And then it maps it, like you would see on, we call them topographical maps, all right? Like the land maps we see. And what we're looking to see here is what color it is, because that tells us from this little scale here whether you're within the normal range. So are you making as much voltage of that delta as a normal sample? That's really what that's showing us. So each head map, each of the frequencies that we're capturing should all look green. All right? If they're all green, then you'd be going, yep,
Normal.
good. At least statistically, you're falling within that normal range where we generally don't have people reporting problems. Okay? As we get to the red hot colors, we're starting to get towards, particularly this red orange, that's 2 deviations away from the normal. And that's generally statistically, that's what we call a significance value. And that is in excess, too much of. And of course, equally the other way, if we're in this dark blue, then we're in absence. We're not making enough of. We can't see enough of that wave. And either one of those is a problem. Okay. So when we now go and look at all of these little isolated maps, we can start to see in the slowest brainwave, everything looks reasonably okay, bit of yellow, but that's okay, not too statistically out there. But on the left, it's red hot. Delta something one is always a little cautious of. Lots of things can cause it that are not real. A very gentle head sway, maybe a little low-grade chewing we haven't been able to clean out of the EEG can lead to an artifact that unfortunately the system doesn't know. It'll just read it as delta brainwaves. Okay? So I'm always a little cautious when I see delta, because something like delta in your left temporal lobe, if that's genuine and real, you do get a little concerned, because we only see localized delta like this where there's potentially been some kind of head trauma.
And that's
So
what we worked that out for me, that whenever I played hurling, like the Irish game with the sticks, like I think I was 14 or 15, didn't have a helmet on and got hit and had 6 or 7 stitches right here. And you said that could be it, and it might not have healed properly or something.
Yeah, and it's possible. There's no 100% certain way of knowing, because we can have delta in developmental disorders where parts of the brain have not wired up fully. Predominantly we see more theta, which we'll get to in a moment, but we can, and yes, in delta we can see that from head trauma, brain injury, brain damage. So you have to go back and look at your history and how significant and where was that head injury. And that would maybe give us a little more confidence to say, it's possible, yep, that brain kind of got a little damaged, and as it healed up, some parts didn't, so we're left with a disconnect in that brain, and that's what's producing the delta brainwave. Other parts maybe did heal up a little better, but not fully, and that can leave you with a theta, a little faster, but still really slow, okay? And even alpha. So you can see all 3 frequencies in these temporal lobes. Kind of does make me think there is something going on in that left temporal lobe of yours, okay?
Yep.
And yes, we can see theta. Certainly we're starting to see a lot more of it in the front and around this left and into this parietal lobe here. So we really have a little bit of a kind of a bias towards your left side of your brain. And theta is a very slow rhythm. You would see more increasing in the brain when you drop off into sleep. So I'm a little cautious in overreading this as well, because your EEG was very drowsy. And as a result of it being drowsy and sleepy, there may have been a lot of theta brain waves being produced as you were dropping off that are, I'm going to say, artificially inflating these levels. However, I wouldn't expect that necessarily in the temporal lobe. Even if you're in that stage 1 drowsy, you see it in this front, You might see it in the back because that's the kind of mechanism in the brain producing that rhythm as we're dropping to sleep. Not so much in your temporal lobe. So there is relevance in what's going on here. And because we've looked at this before, into this parietal lobe here, those levels were a little more excessive than I would expect. And so it does suggest possibly maybe it's related to some of the head bump, or maybe it's related to developmental issues. So language development, reading, writing, learning where languages are involved.
Yep.
So that's kind of how we would generally look at an EEG. You don't jump to a conclusion straight away about what you're seeing. You're looking at the relevance. You're looking at whether it's real first. You're looking at the relevance to the person's symptom history so that you've got confirmation. And once you've got confirmation, let's say in this case, yes, there's something going on in your left temporal lobes. You've clinically tested for and reported issues with your verbal memory, with maybe even auditory processing, so not always following conversations. That's an area that we would then look to target to treat.
What about the beta? It looks just inflamed.
Yeah,
What
and I
is
think
going
for
on there?
me, that was probably the biggest standout in your EEG, is that you were making this what we call beta 1, so it's not as activating as the faster brain waves here, but it is an active kind of a calm active state in the brain, but nevertheless it was quite elevated also in this parietal lobe and in this frontal lobe as well.
What does that mean?
What does
How
that
does that
mean? I mean, if
express
we had,
itself?
yeah, sure. If we had none of this kind of other stuff here, if everything was green and all we saw was this elevation in beta 1, you would wonder about how active that person's brain actually is. Is it maybe a little sped up in the background? Is it a little overactive? So a brain that maybe doesn't switch off, that's incessantly thinking, excessively processing information, maybe too quickly processing information, and can drive a little bit of anxiety, can drive a bit of hypervigilance in the arousal language, right? I can be a little hyper aroused. Okay.
Yeah.
That's what an excess of the beta brainwaves would generally be concluded to do.
And can that come from, like, say, childhood trauma? Can that come from, like, a knock on the head? Like, how does that produce itself?
Yeah, in the early stages of a knock to head, you often do see an increase in beta as well as an increase in slow. So that's a possibility. I don't believe that's the case in yours. Is it a developmental thing? It can be. It can be purely genetically driven, that we tend to just make a lot more beta brainwaves, and there's probably a little bit of evidence further down in your EEG that I felt kind of supported that when we talk about the dominant peak frequency in the brain. That's the inherent speed of your brain that has a very strong link to what we inherit. Yours was fast. So that extra evidence kind of makes me go, maybe that's why this brain map has picked that up, because your background rhythm in your brain is fast.
I
So
always tell people that I'm
beta
really quick.
brainwaves, right? This could be what we call fast alpha. That's where this gets really technical, and I don't want to lose you or your audience. But yes, it can be driven genetically inherited. It can be through some people with PTSD, post-traumatic stress, right? Speeds up the background EEG because we're in a constant state of hyperarousal, hyperawareness. So we call that a norepinephrine response or a noradrenaline response. And norepinephrine is kind of responsible for increasing the background speed of the EEG. This is why in ADHD, often the drugs you're given are drugs that boost norepinephrine in the brain to speed up a slow, sluggish, sleepy brain, which is commonly what we see in ADHD. So there's a third possibility, and that is it could be compensatory. Meaning, if I'm that sleep deprived, my brain might be making these bursts of slightly faster rhythms to try and counter
Yeah.
vigilance, counter the fact that you're getting sleepy to keep you awake and keep your brain working. Helpful, all right, when we look at your eyes open, helpful to keep your brain functioning, but is not without its own side effects. It means we can feel stressed, we can get anxious more often. So there are many things, and again, through our dialogue and our clinical interviews, we get to piece that puzzle together of what it more likely is representing.
Cool.
So yeah, I mean, this was yours. And so if we jump and go, well, how does that contrast then with your eyes open? Obviously, we're hoping to see all of these green in your eyes open. And what we see in your eyes open, we don't need to go through all of the EEG, but you can already see in the raw file, it looks very similar with these big bursts of alpha and then a bit of a dropout in these big bursts of alpha. Very similar to your eyes closed. So it's telling me that when your eyes were open, you were still very drowsy. Okay. Very, very drowsy. And that continued all the way through. There are individual pieces of the puzzle, like parietal 3, that really, this is such a big burst and it stands out from the rest, that it may not just be drowsiness. One would look at that and go, it's a little more biased to the left hemisphere, it's a little more increased. Is there something actually going on in your parietal lobe? We see it in this temporal lobe as well at times. So, yeah, there's a bit more evidence in your eyes open that confirms there is other things going on beyond just the sleep deprivation that we're seeing in the overall pattern. Okay.
Yeah.
So when we look at the colorized, again, just for comparison, you'll see again, we've got that kind of delta pattern still there. We've got a strong slowing theta, except now we're seeing it a little bit more even in the right of your brain.
So what you're saying, this is supposed to be all green if it's a healthy,
be all green.
normal brain,
Yeah.
right? Okay.
Yeah. Okay.
Kind of scary.
But we're seeing in the left part of your brain and the right part of your brain, where the brain should be alert and active and attentive, that we're getting temporal lobe slowing, very much in the left temporal and the right temporal lobe. And, functionally, one would expect someone to be struggling potentially with language and learning, comprehension and processing at any particular speed, possibly memory.
Yeah, memory
Right? And these go
shocking.
beyond ADHD attentional network stuff. This just looks a little different. We've certainly got a lot of alpha, the slower alpha, in the same areas. You see it in the same kind of pattern. Right? And yes, the drowsiness, the lack of vigilance and alertness is represented by this. So we don't want to overread it. I suspect this alpha 2 is probably more representative of that ongoing drowsy state that you were still in with your eyes open.
I don't even know what's
that's not
happening.
helpful.
It doesn't even register.
No.
Like with me, like I remember my wife always used to crack it. Like if I would have like a yawn, like if I'm speaking to someone, like I have this like micro yawn, she was like, "That's so rude," and I literally don't even know I'm doing it. Like it's just, yeah, it's subconscious for me.
Yeah. At best, one can look at this and go, how are you able to maintain focus and maintain vigilance, alertness, attention? It's very difficult, because every 3 seconds in this EEG, your brain is moving into kind of stage 1 sleepy wave, right? So think of it that way: as you're talking to someone and your brain is dropping in and out of a sleepy state.
Yeah.
Now, in adults, we do see this slower form of alpha generally in the front, right? That is a common ADHD finding, right? Mostly in the front, because ADHD is a frontal executive dysfunction disorder. So we tend to see it more in the front. Okay. The fact that your whole head's kind of showing it is the sleep, but we've also got more than that stock standard ADHD pattern going on with some stuff happening in your temporal lobes, that's not helpful. Okay, in my view, goes a little bit beyond the typical ADHD pattern. That's not the pattern that we would see purely in ADHD. It would be this kind of just red all across the front. In children, more often you see theta across the front, or right, an even slower rhythm dominating the front.
Yeah. And I suppose it's good for me to share that I got diagnosed with adult ADD probably before it got trendy, maybe 3.5, 4 years ago.
Right.
And I was prescribed Ritalin. And I think we talked about it. Whenever I took the Ritalin, it was amazing in the sense of I could focus. Like it was like shutting off all the tabs on my computer and leaving one open. And the noise just dropped, and I couldn't believe it. I cried. It was like night and day at this stage. As time has went on, I have noticed side effects of, if I take it first thing in the morning, I crash mentally at lunchtime. And we spoke about that. And whenever I get diagnosed with ADHD, there was no brain scans. There was no like blood tests. I think I'd done like a heart test, I think. And I think I actually did have my bloods checked, but they wanted to see my school reports from primary school. This was the main thing, and I don't know why my mum kept them. And I'm sure everyone's primary school reports were the same. Like so much potential, doesn't sit at peace, walks around the classroom, thinks he's a policeman. He never stops walking. He can't sit at peace. Blah blah blah. Like I'm sure most reports in primary school are like that for people, but that was what got me across the line to get diagnosed and to be able to get the prescription. And then that was, I suppose, what brought me to see you, because ADHD and sleep, there's like cofactors, like there's links in that. But as you said, this goes beyond ADHD from your perspective.
Yeah. So, it may be why, in many cases, people will have good response to the stimulant medications. They might have had to try Ritalin and then move on to an amphetamine like Vyvanse, or before they get that benefit. But there is always remaining issues that they still struggle with, and so that's where this can be kind of helpful to see. Well, yes, the modafinils all the way through to the stimulants are likely to address some of this slow stuff because they are stimulants. They counter-vigilance drugs. So they're increasing a little bit of the background beta brain waves, and through their mechanisms would be suppressing some of the slow stuff. So the brain would then feel like it's functioning normally, right? That's the benefit of it. But of course, if we then looked at it again and we still had this stuff happening in the temporal lobes, then one would kind of go, well, you may have a language learning disability that's comorbid with this, or in your case, maybe this is still a part of some earlier head injury that is impairing some of the functioning on the left and maybe disrupting language memory and so things, which the stimulant meds may not entirely address, of course. And so that's where we have to then think, what else can we do to try and get these parts of the brain a little bit more online, a little bit more activated? So it's not that we could look at this and have it as a diagnostic of ADHD. It's very helpful. And it's why most psychologists and psychiatrists won't look at this. And probably where QEGs come under a lot of criticism is, I think those criticizing it are thinking or assuming that it is being used to formally diagnose. No, it's not. It can help understand which form or type of ADHD, once you've got all of that background historical evidence that it exists, what type. And in fact, there is even an emerging field of being able to match the medication to what is dominating.
Right.
So if you only had frontal theta brainwaves dominating the front, then the research literature shows that things like Ritalin seems to be more effective in that kind of type. And if you've got the more sort of, if you didn't have any of these, you just had this faster alpha type. We've even seen what we call an SNRI, selective norepinephrine reuptake inhibitor, as an antidepressant actually be quite effective in some of those ADHD populations. So, it's the field of precision medicine that is growing, or what's known as stratified psychiatry, which is, do we need to use the drug that was researched and purposed for, say, ADHD, only for ADHD? Or is it possible to start to address the underlying biology and then match the best medication for that underlying biology? And I mean, that's a complicated field, of course, but that's where some people have used and shown that thyroid medication can be as effective as a prescription antidepressant, for example. Well, knowing what might be the underlying driver behind that depression and then matching that medication can be life-changing. So that's where I believe the field is moving, and there's a lot of research looking at DNA and bloods and brain scans to look for these things and being able to try and treat the biomarkers, as I said, rather than the label, because it's actually quite unreliable.
And Ryan, is there any standout, if you could give the audience a couple of things to look out for, say, in someone's blood work, or a couple of things to sort of look out in someone's genetic testing? Is there anything that you go, I remember we talked about the copper ratio with, what was it, copper and
zinc? Yes.
Yeah.
So there certainly are. And, I think, in our kind of conversation, one of the things that drove that was for me to go, well, why are you not sleeping so well? What's causing that? And, looking at that speed of your brain, that background rhythm that we can only pick up at the back, most dominant alpha frequency rhythms will have stabilized, matured, been wired in by age 10, all right? It kind of continues to about age 16 as the brain is still developing there, but it's mostly settled, should be between 9.5 and 10.5 cycles per second, just like a car, right? Brum, 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 the idling. So we can measure that with a lot of accuracy. And if it's at 8, really slow at the start of alpha, and it hasn't gotten any faster than that, there's a lot of evidence to show that that correlates with an intellectual impairment, if not an intellectual disability. Okay, so we're looking at that. Yours was outside of that. Your speed was sitting at about 11.5. So that's helpful to know, because that tells me that it's most of your alpha's in the normal range where it should be. So I would expect your ability to pay attention, process information at an adequate speed, and have reasonably good ability to draw information out of your memory. So good recall, right? That's what that data shows us. So 11.5, you go, oh, well, that must be even better. It's so much faster. It's outside of that norm. And yes, in some ways it is. Clinically, I personally see it in a lot of our execs, and it doesn't mean you have higher IQ necessarily, but it means your brain has this capacity to process information very, very quickly. But that can be a problem too, meaning my brain's too fast, it's always on, it's turned on, it's highly activated, and I can look ADHD. Right? Ignoring all the other stuff we looked at your EEG, just that alone, you can come across as ADHD because your brain gets bored with slower conversation, slower dialogue, because it's 10 steps ahead of it, right?
Yeah.
So that's why you'll see it in a lot of CEO brains and entrepreneurs' brains. I mean, they're quick. It's like, get to the point, mate. Hurry up. I've got 5 minutes, and
Skip
then
the
I'm
small
going to lose
talk.
interest and move on. Yeah. So that's helpful to know, because what can speed that up, what we know chemically speeds that up, are your norepinephrines and your choline, your acetylcholine. They tend to be the drivers of what we're seeing in the back there. And so that led me to, probably talk to you about your bloods, because most of it, I would believe, might be something we're born with. But I have seen and read that it can be sped up in trauma, because the brain is then being bombarded with that stress hormone. and that can speed things up. And it can also potentially be sped up by an excess of copper. And that is because copper and zinc are our two really important cofactors to help neurotransmitters be produced. So zinc, we test for it, a lot of doctors talk about it and we measure it, is probably more important in the serotonin kind of pathway and production of serotonin. I don't want to, it's a bit reductionistic, but that's where that seems to be more relevant. Copper plays an integral role in your dopamine production and dopamine's conversion into norepinephrine. So why do we look at, and why do a lot of functional medicine doctors look at how much zinc to copper you've got? Generally, clinically speaking, you want it 1-to-1. So as much zinc as you've got, as much copper, and both of them need to sit within that normal range, okay? When we've got more copper, even if we're both within the normal ranges, but we've got a lot more sort of copper, the understanding we've got is that they compete. They kind of keep each other in check in a way. So zinc competes, and if zinc is higher or about the same, it can keep that copper level in check. But if the copper's in excess, it means we've got a lot of free copper floating around. And it's that free copper, that increase in copper, that is likely to then start to increase the conversion of dopamine into norepinephrine. So what that might end result be is a lowering of dopamine because you're getting more being converted into norepinephrine, and that can leave us a little ADD, right? I'm not suggesting this is the primary cause of ADHD at all, but it can help us understand sometimes when medications aren't working very well, that we've also got this other issue that might be driving and making things more complicated. So in your case, an increase in norepinephrine may be responsible for the increase in the background rhythm of your brain, which would have ramifications for sleep, right? Because if I'm trying to sleep at night and I've got too much norepinephrine or noradrenaline in my brain, my ability to drop off into sleep is going to be problematic.
Yeah, and you said that it wasn't my body wasn't getting rid of the neuroephedrine as well.
Yes. So, is it a copper issue? We would look at your bloods and we would kind of work it out from there. What else could be causing that faster brain? Well, it can be driven by a gene, two genes in particular, but the strongest is one called the COMT catechol, and it's commonly talked about in those DNA reports. It has probably some of the strongest evidence alongside the second one called the MAOA, your monoamine oxidase. Both of those produce an enzyme, and that enzyme helps to break down norepinephrine, serotonin, dopamine, estrogen. So it kind of breaks down all of the amines, the catecholamines, to help the body get rid of it. Okay. So we make these neurotransmitters and the body needs to break and get rid of them. And so we can carry a variant in that COMT or MAO that makes it slow and sluggish, so we don't break it down as fast, and that would leave this excess of norepinephrine in your body. Okay.
Yeah, so it's fascinating.
And that's why you're looking at your EEG, but you also want to have your bloods and you want to have your DNA, because that way you're getting the full story. You're not just getting a part and making a diagnostic assumption. You're really trying to get the full picture of all the systems involved. And that then empowers us to go and say, right, nutraceutically wise or nutritionally, what can we give you to try and counter that variant that you've inherited in your DNA? And if we can improve that, and it's not just nutrition, I would give you the advice of saying don't exercise at night, because exercising at night, you're not going to get rid of norepinephrine, and so that's going to impair your sleep, right? So do it only in the morning. So we can tailor strategies around that understanding of your brain, your blood, and your DNA to get you into the most optimal functioning state day to day.
Yeah. One thing that's really worked, like as basic as it is, was the sleepy tea, the passion flower sleepy tea. Like
Yeah.
noticeably, like consistently better sleep. So if I drink a mug of that, like within an hour before bed, like that's crazy to me that that's such a simple
Yeah.
thing you just get at the shop.
Yeah. Yeah. Yes, so that's one of the strategies we use is knowing that we've got all of these activating chemicals. We need to try and increase some of the calming ones. Again, not having looked at your DNA as yet, but whether you don't make GABA even. There might be some genetics you've inherited there as well, right? So we've got a double storm going on. I make all this excess fast stuff and I'm not making the slow stuff that helps my brain calm and transition. So that's what we're doing when we're giving you these herbs and these teas is, some, not all of those components have fairly good, robust research science to show that they do improve your GABA uptake in the brain. And so that's partly what we were doing, is to boost that GABA level as a way to try and counter some of that excess epinephrine, norepinephrine that you may be carrying.
Yeah, it's fascinating. I'm so glad that I found you and we're getting to the bottom of things, because I know we have to still look at the DNA, but I know things have definitely improved incrementally, which is great. And I've one of my best mates, he's actually come to see you today, and he's excited and he just loves the whole learning more about how to optimize his brain as well, because that's what it comes down to. It comes down to just becoming the best version of yourself. Like I'm 43, coming into her 40s, family now. You want to just be able to have the best active life, and what can we do to actually improve that? And I mean, you're leading the game whenever it comes to holistic. You put a new definition on holistic. People call themselves holistic healers and holistic medicine people, but if they're not taking in the brain, they're not holistic in my view. Only now, after working with you, that I've realized that.
Yeah,
So
yeah. And look,
brilliant.
there's cautionary notes around all of this, isn't there? It's such an emerging field. Some of this is still very much in the experimental phases, and I think we have to qualify that. There isn't research data that the medical community or the science community would want on, do all these things, when you do them all together, treat this condition, do they lead to longevity and longer outcomes? We don't have that data.
Yeah.
It's building. It's definitely building through some of the big RDoC trials in America, but we're still a way away from being able to say, yes, these solutions in these three domains will treat your depression. So one cannot make all of those claims, and I think that's really important to know. But where we're not getting success with the current kind of system, and if we know that by doing these things we're not doing harm, at least we've got that evidence, that safety evidence to show we're not doing harm, then there could be an argument to say, well, why wouldn't we go down these pathways? Even though the data is still in its earliest phases, why wouldn't we if something else hasn't been working for you?
That's it. You have to get the data somehow, so it's good that people are exploring it.
Absolutely, yeah. So I think as long as people are made aware of that in a responsible way, and it's not sold as this magic bullet, to individuals. And Pete, on the other side, it also takes commitment and time. Changing and countering our DNA, or improving and fixing the functioning of the brain, it takes time. And so a person has to be committed to that 6 to 12 month process of building these things in, testing them out to see if they work for themselves, and then sticking with that plan, right?
Yeah.
And I think
Test
that's
and
the
measure.
biggest challenge.
Yeah. I had a question from a friend of mine, Bridget. She asked about long COVID. We didn't touch on COVID because it's not really a nice thing to talk about these days. But is there any correlation with long COVID and, I suppose, brain health? Is there any data out there these days?
Absolutely. Yeah. Look, they're every day you're seeing a new research paper coming out to try and help us understand why those with COVID long are complaining of various brain issues. Of course, the common one being brain fog, and jointly with that, fatigue within the body, and memory issues. Forgetting people's names and not able to recall names, usually being really good at recalling. There's no one yet, I think, that has kind of pulled it all together into a very meaningful space, but that is happening. But the data that at least I've been reading, some of it's quite disturbing. Some of it has been showing that there are brain cells fusing together as one potential mechanism and explanation for why we're having these long COVID. There are other researchers suggesting this will lead to a whole new rise and wave of Alzheimer's disease because of the harm and damage that it's kind of doing in the brain. There's definitely research showing, these senescent cells, are in the brain post-COVID. So, we commonly talk about senescent cells in the body, these kind of dying cells that are not good. I mean, those are the ones that often turn into cancer and can cause kind of issues. There's research on inflammation, definitely showing that there is an issue with the microglia in the brain, that they're getting primed in an inflammatory way. Blood flow. Some of the EEG studies are showing slowing in the temporal lobes, similar to what we looked at in your EEG, right? Because of inflammation and possibly sort of playing a role with the basal blood flow artery into the temporal lobes, we're seeing these kind of EEG changes as well. That was some of the stuff coming out in 2021. Wow. So there's a lot out there, and technologies like this can be helpful if a person has had COVID and you want to look at the brain and kind of see where it might be struggling. But again, it's not, oh yes, you must have had COVID. You cannot confirm from an EEG that person has had it, because as we've spoken, there can be other historical factors things that might have actually driven those issues, right? But at least we can still know, in my case, often if I'm seeing the temporal lobe changes, is we can even use things like infrared treatments, so photobiomodulation, to shine into the brain to increase blood flow, reduce inflammation, and try and repair some of the damage that's been done by some of these conditions, from concussion to COVID itself.
Interesting. Interesting, mate. Yeah, we could talk for days, and I love whenever we catch up because it's just so interesting and fascinating. Do you work with people overseas, Ryan? Is that applicable for you, or do they have to be in Melbourne?
I haven't yet. I certainly work with people interstate. The challenge often is, how do you get an EEG? I definitely have a lot of Australians living overseas that come and visit Australia, and often will do EEGs, and then I'll continue to remotely connect with them and support them. So that's increasing, actually. It's been increasing in my end. But yes, if a person was overseas, depending on the country they're in, we would want to try and facilitate
getting
at least the EEG being done. But everything else, DNA tests and stuff like that can all just be sent on, and one can look at it and try and make sense of it.
Cool. That's good to know. Awesome. So people wanting to know more can head to your website, www.neuroperformance.com.au. Anywhere else they can connect with you? I think you're on LinkedIn. Is that it?
Yes. I'm on LinkedIn, and that's pretty much it. Websites and LinkedIn are the main two areas that you'll probably see me.
Cool. Awesome. Well, we've chatted for just an hour and 15 minutes. It's flown, but thanks so much for coming on. It's been great. It's been fascinating. And hopefully, some of my network or the listeners might reach out and connect with you as well, and see how they go. But thanks a million, and we will definitely chat soon.
Thanks, Pete. Enjoy the conversation.
I will. All right. Cheers, mate. Bye-bye.
Thank you.